Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is important concepts of measure of averages and spread. An important advice for me and for everyone, we should always dress properly. Data. Data has two types. Ungroup, that is the raw data. Group, that is the frequency distribution. Measures of central tendency. The following are three types of measures of central tendency. Number one, the mean, the median, number two, and number three, the mode. Measures of spread. The following are four types of measures of spread in our syllabus. Number one, the range. Number two, the interquartile range. Number three, the standard deviation. And number four, the variance. Well, all these types of spread show the variation of the observations from their mean. Their small values means less variation, and their large values means more variation. We can understand the concept of measure of spread through this example. We have two players A and B, and these are their scores of the first three innings. The scores of their first three innings. The averages of these two players are same, 40 and 40. You cannot compare these two players through their averages. So you have to find either of the quantity of spread. You can either find range or IQR or standard deviation or variance. Let's suppose we have found the IQR of both the players. Since the IQR of player B is less than the IQR of player A, therefore player B is more consistent than player A, because the observations of B are less scattered from their mean than the observations of A. I already have told you this thing. The small value of IQR or range or standard deviation or variance shows the high consistency of the quantity and vice versa. Hence, small values of these quantities means less variation, meaning observations are less scattered from their mean, like in this case. These observations are less scattered from their mean. And the large values of these quantities means more variation, meaning the observations are more scattered from their mean. Ungrouped data. Well, for ungrouped data and for odd number of observations, this is the formula of mean, sigma x over n. Well, we will use the same formula for ungrouped data whether the n is odd or even. So the formula is same for mean, and we will use the same formula for median whether the n is odd or even. Through this formula we can get the median, but make sure your data must be arranged in ascending order for median and for quartiles and for percentiles as well. Well, lower quartile, make sure you will learn these two formulas, this one as well. But for ungrouped data and for an odd number of observations, this is the formula for Q1. It is 1 upon 4 n plus 1th observation, and this is 3 upon 4 times n plus 1th observation. This is like this. You can write this as n plus 1 upon 4th observation in this way as well. Three upon 4 n plus 1th observation. You all know how to find mode. It is the most repeated observation. And you all know how to find IQR. It is Q3 minus Q1. So let me write the formula of IQR here. It is Q3 minus Q1. And semi-interquartile range. Semi-interquartile range, the formula is Q3 minus Q1 upon 2. Ungroup data and for even number of observations. See, the formula of mean is unchanged, the formula of median is unchanged, but very important, the formulas are quartiles. They are changed. They have changed in fact. So this is the formula of lower quartile. It's n upon 4 plus 0.5th observation. And for Q3, use this formula 3 upon 4n plus 0.5th observation. And this is the formula of IQR. What if we have n 12? So by substituting 12 here, we have 12 upon 4 plus 0.5. That means 3.5th observation. Now 3.5 means the average of third and fourth observation. Make sure you learn these two formulas as well. So the formulas are changed for ungrouped data and for even number of observations for quartiles. So these two formulas are for ungrouped data and for even number of observations. And these two formulas are for ungrouped data and for odd number of observations. For odd number of observations, use these two formulae, and for even number of observations, use these two formulae. And the formula of median is unchanged. They use the same formula for median for group and ungrouped data. You can view this here. You can compare the formulas here. See, the formula of median is unchanged, formula of mean is unchanged, but the formulas of quartiles are changed. This is 1 upon 4 n plus 1 observation, and this is 1 upon 4 n plus 0.5 bracket observation. Well, for group data means frequency distribution. This is the formula of mean, and this x means class centers or mid values. Median class, not median class, this is just median. We can find median class from histogram. So if you are working for median from cumulative frequency, then it is the 50%. You just need to, what if this is the cumulative frequency curve? So you just need to take 50% of this number. Let's suppose this number is 80. So this is the median. So it is the 50%, median is the 50% of total frequency's corresponding value. 50% is 40 and 40th corresponding value is median. So this is median. And Q1 is 25%. 25% means the half of 40, or like 25% of 80 means 20. So this is Q1. If you take the average of lower frequency and this frequency, then you will get 20, and this is Q1. You have two options for Q1. Either take 25% of this total frequency, which is 20, and get the quartile, or take the half of 40. The half of 40 is 20, so this is Q1. And if you take the half of 40 and if you take the average of 40 and 80, then you'll get 60, and this will be Q3. And the other way is take the 75% of 80, which is 60, and get its corresponding value. This is the way to get Q3. So you have two methods for getting Q1 and Q3. It's your choice. Well, I mean, which method is easy for you? Use that method, which one is easy? And 80th percentile. This is so simple. If it's 80, so write 80% of total frequency and then estimate it from the cumulative frequency graph. Well, we get model class from histogram. It is the highest frequency density class. The highest bar. Let's suppose this one is the highest bar. So this is the model class. If we have 20 here and 30 here, so the model class is 20 to 30. This is for group data and continuous group data, in fact. This is for ungroup data. These formulas are for ungroup data. Standard deviation. This formula is given. Well, this formula will be given in CIs. Standard deviation is denoted by sigma, small sigma. So these two formulas will be given in CIs. This is sigma x square over n, and this is x bar square. And this is sigma x minus x bar whole square upon n. N means total number of observations, where x bar is sigma x over n, and x bar means the mean. Well, sigma x square is never equal to sigma x whole square. These two things are different. This means sum of the squares of the observations. If we have these three observations, then if we will take sum of their squares, then we'll get sigma x square. So sigma x square is the sum of the squares of the observations, like 1 square plus 8 square plus 12 square. This is sigma x square. Sigma x you all know, it is the sum of all the observations. And sigma x whole square means the square of this, which is 441. So 441 is not equal to 209. Therefore, sigma x square is never equal to sigma x whole square. Variance. Variance is denoted by sigma square. We denote variance by sigma square or Vx. This x is capital. And these two formulas will be given in exam. If you observe these two formulas, you will see that square root has been removed from these two formulas. I mean, if you will remove this square root and this square root, you can get the formulas of variance, because variance is the square of standard deviation. So when you square here, then you'll get the formulas of variance. So if standard deviation is 2, so by squaring 2 we can get variance. Or if variance is let's suppose 9, so by taking square root on both sides we can get the standard deviation. Well, these are the ranges of variance. Normally, we suppose if anything is less than hundreds, if sigma square is less than 100, then we assume that variance is small and less variation. The observations are less scattered from their mean. And we suppose this value like 144, more than 144 means if sigma square is more than 144, that means more variation, which means the observations are more scattered from their mean. If sigma square is 0, that means no variation. That means all observations are exactly the same as their mean. What if we have these three observations? See, their mean will be 5 and their standard deviation must be 0 or variance must be 0. Why? Because there is no variation of the observations from their mean. All observations are same as mean. So when all observations are the same, then standard deviation or variance must be 0 and will be 0. Measures of central tendency: mean, median, mode. This is the formula of mean, sigma x over n. This is the formula of median. Whether n is even or odd, use the same formula. Mode means the most repeated observation. Well, mean is always affected by the extreme values. Therefore, mean cannot give the clear picture of the data when the extreme values are too large or too small. Mode is also affected by the extreme values. Sometimes data has no mode. So these are two disadvantages of mode. Number one, mode is always affected by the extreme values. When the lowest observation is repeating or when the highest observation is repeating, then mode cannot give the clear picture of the data. And sometimes data has no mode. Well, median is more suitable or is the most suitable type of central tendency because median is never affected by the extreme values. Well, calculations of mean and variance by assume mean method. This is the topic. Calculations of mean and variance by assume mean method. Assume mean means this letter A is assume mean. This B is assume mean. This means if you solve a question, if I ask you get the average of these observations, if I ask you find the mean of these observations, these 4 observations, so whether you will use this formula or this formula or this formula, you must get the same answer because the observations are unchanged. So these are 3 different methods of calculating the mean. So to make calculation simple, we normally use these formulas when data is very large. Like when we have high values, when we have high observations. Like in this case, 200, 210, 213, 193. These observations are high or large. So if I ask you get the mean of this data without calculator, then by assume mean method you can easily get this answer, the mean of these observations. So this is the concept of using these formulas. Well, so we have 3 different formulas of mean. This is the simple formula and this will be given in exam. This is the assume mean and we have got this formula by replacing this A by B. If you replace A by B, you can get this formula. So whether you use this formula or this formula or this formula, you must get the same answer and you will get the same answer. Sigma square. Well, this is the formula of sigma square and let me make it simple. Give me just 1 minute. Well, we had x bar here. X bar means sigma x over n. This means x bar. So and this formula will be given in exam. So if you replace x by x minus a by replacing or replace x by x minus a here and here, you can easily get this formula. So if you will replace this x by x minus a and this x by x minus a, you can easily form this formula. So you don't need to learn this formula. This formula will be given in exam. So you just need to replace x by x minus a, and x by x minus b here and here. If you want to learn, that is very good, but if you cannot learn these two formulas, you can make these two formulas in exam by replacing this x and this x by x minus a. So we have three formulas for variance, and I already have told you that sigma x square is never equal to sigma x whole square. Since this is not equal to this, therefore sigma x minus a whole square cannot be sigma x minus a whole square. Now this is very important. This is one of the most important concept. I already have explained these formulas. Now how will we use these formulas? See, sometimes we need this relation. Maybe sigma x is unknown and we have n, we have sigma x minus a, we have a. So if we have all three informations except sigma x, we can use this formula. We can use this relation. And with the help of this relation, we can easily get sigma x. So if anything is unknown in this relation, so we can easily get that thing by using this formula. And we can also use this formula if, let's suppose, this information is missing and this is given, this, and this is given. So we can easily get this information. So make sure you understand, this relation and this relation. And in my opinion, you should learn these formulas, because we need to use this relation and this relation during questions. Well, this formula and this formula will be given in exam, and I already have told you how to make this formula. If you replace this x by x minus a, you can easily get this formula. And there are four relations. Number one, this. Sometimes we use this. Sometimes we use this. And this one and this one. We will learn how to use these relations during questions. But this page is very important. If you learn this page well, and if you understand and then learn this page, then you will be able to solve all the questions of these types. Now the next topic is addition of new observation into previous data. Addition and subtraction. This is for both. If you either add or subtract, you have to use the same concept. Well, this is the original data. This is the data for 36 observations. Let me just correct one thing. This is not x, this is n. Well, sigma x is this for 36. This is sigma x minus 45. And this is sigma x minus 45 whole square. Now this data is for 36 observations. Now a new observation, which is 29, was added to the sample. Now get the values of sigma x minus 45 and sigma x minus 45 whole square. See, you can directly add x into this data. This 29 means the new observation. This 29 means x. That is, x is 29. So, see, you have to add x here. This is x. So just add 29 here. If you add 29 here, you can get sigma x for 37 observations. But you cannot add 29 into this data, because this is not x, this is x minus 45. So you need to add 29 minus 45 into this to get sigma x minus 45 for 37 observations. This concept is extremely important. I don't have the calculator, otherwise I could evaluate this thing. You should evaluate this thing yourself, and this as well, and this as well. So make sure when you add something into this, you can add directly. You need to add 29 into this, you can add 29 directly into this, and you will get the answer. And this number will be for 37 observations. But you cannot add 29 directly into this. You cannot write minus 148 plus 29. Why? Because we have x minus 45 here, and x means 29. So you have to add 29 minus 45 into this data. And this the answer will be for 37 observations. Same is here. You cannot add just 29 into this data. You just need to add 29 minus 45 whole square into this, and this number will be for 37 observations. So this is the way to add the new observation into previous data. And the same way will be used when you need to subtract something from the data. So for subtraction, you must have negative sign here. When you have to add, then put plus sign here. When you need to subtract, what if the question is subtract 29 from the data, then write negative here. And this concept is extremely important. Now, the next topic is the combined mean and combined standard deviation. Well, we have two formulae for combined mean. You need to learn these formulas. Either learn this or this. This formula is better. You need to learn this one. And you can easily learn this one as well, because combined means the mean of two groups, like group 1 and group 2. So this is the total of group 1, this is the total of group 2, and this is the total number of observations in group 1, and this is in group 2. So this formula is very simple. You know, x bar is sigma x over n. So sigma x will be nx bar. So if you will replace sigma x by nx bar, you will get this formula. I suggest you to learn these two formulas, because sometimes we need this formula, sometimes we need to use this formula. Well, standard deviation. Standard deviation formula is this for combined standard deviation. This is so simple. You know this formula. If I remove this square, this is the formula of standard deviation. You just need to add sigma x1 square and sigma x2 square. Just replace this by sigma x1 square, sigma x2 square, this by n1 plus n2. And this is combined mean. Sigma x square. Sigma x square, you can get sigma x1 square from this formula. If you make this sigma x square subject from this formula, you will get this result. See, if I need this thing, then I need to shift this on left hand side. So this will become sigma square x bar square, and on right side we have sigma x square over n. So sigma x square will be n times this bracket. See, you need to learn these formulas. Only this will be given in CIs. And I told you, you can easily form this formula. If you will replace sigma x square by sigma x1 square plus sigma x2 square, and n by n1 plus n2. Properties of mean and standard deviation. So, number one, if observations are same, for example, if all the observations are 3 each, like this one is 3, 3, 3, 3, then mean will be 3. And standard deviation must be 0, because there is no variation of the observations from their mean. Property number 2. Well, if you multiply each and every observation by a non-zero constant like a, you multiplied x1 by a, x2 by a, and x3 by a, then you need to multiply their mean by a and their standard deviation by a. So if this is, if this is the original data, x1, x2, and x3, and if their mean is x bar and their standard deviation is sigma, so if you multiply each and every observation by a non-zero constant like a, then you should multiply the mean of this data by a to get the mean of this data, and standard deviation by a as well. So mean and standard deviation will be changed when you multiply each and every observation by a non-zero constant. In fact, you need to multiply their mean by that constant and their standard deviation by that constant as well. So this is the property number 2. Now again we have the same data x1, x2, x3, and their mean is x bar and their standard deviation is sigma. So if we either add or subtract a non-zero constant into each and every observation, for example, we are adding a into each and every observation, then we need to add that constant into their mean. But standard deviation will be unchanged or will remain unchanged, because standard deviation will only be changed when you multiply each and every observation by a non-zero constant. And when you add or subtract a non-zero constant into each and every observation, then standard deviation will be unchanged or will remain unchanged, but mean will always be changed. So this is the property number 3. Let me summarize these properties, because these properties are very important. Number 1, if all observations are same, you can understand this as if all the observations are same. If all observations are same, then for example 3 3 3 3, see, all observations are same, so their mean must be that observation. Like if the observation is 3, then mean will be 3. If the observations were 5, then mean will be 5. But standard deviation must be 0, because there is no variation of the observations from their mean. This is property number 1. Property number 2. We have 3 observations, x1, x2, and x3, and their mean is x bar and their standard deviation is sigma. Now property number 2 is when we multiply each and every observation by a non-zero constant, then we need to multiply the mean of those observations by that constant, and we need to multiply their standard deviation by that constant as well. We multiplied each and every observation by a non-zero constant a. Therefore, we need to multiply x bar with a and standard deviation with a as well to get the new mean and new standard deviation. You don't need to calculate the mean of this data. You can easily get the mean of this data by multiplying this mean by this constant and this standard deviation by this constant. This is the property number 2. Property number 3 is when we add or subtract a non-zero constant into each and every observation, then we need to add or subtract that constant into the mean of that data, but standard deviation will remain unchanged. Now this is the group data, and the formula of mean for group data is sigma fx over sigma f, and the formula of variance is this: sigma fx square over sigma f minus x bar square. Important examples. Well, these questions are from my practice book. Question number 7. Esme noted the test marks X of 16 people in a class. She found that sigma X is 824 and that the standard deviation of X was 6.5. So we have two things. We have in fact three things. This is N. This is given sigma X and this is X bar. Sorry, this is sigma. And we need sigma X minus 50 and sigma X minus 50 square. Now I will use these relations. These relations. See, sigma X upon N, sigma X minus A upon N plus A. We know this relation. We just did this. So we have sigma X, we have N. We need sigma X minus 50. See, this is A, so this is plus A. Since this is 50, so this must be plus 50. So we can easily get this, the value of this quantity. So by shifting 50 on this and here, by shifting 50 here and multiplying 16 here, we will get this thing, 24. When we will solve this and when we will bring 50 on left side, we'll get 1.5. When we will multiply 16 with this, we'll get 24. So that's the answer of this thing. Now we need sigma X minus 50 square. This is simple. We have standard deviation, which is 6.5. So we have to use this formula. Sigma X minus 50 whole square upon N, which is 16. Sigma X minus 50 upon 16 whole square. We have sigma, which is 6.5. We have this as well, which is 24. So by solving this, we can get sigma X minus 50 whole square. Now this, we just did this concept as well. One person did the test later and her mark was 72. Calculate the new mean and standard deviation. We have to add this 72 into this data first, or into this data. Now number 1, get sigma X for 17 people. This is the sigma X for 16 people. So when you will, since you have sigma X, so you can directly add 72 into this. So when you will add 72 into this, you'll get 896, I guess. Let me check this. 824, 72, 6, yeah, 896. See, so the answer is 52.7. Now for standard deviation, you need to add 72 into this data and into this data. But make sure you carefully add 72 here. See, here we had just X. So we added 72 directly into this. But here we have X minus 50 and X is 72. This 72 means X. Observation means X. So the answer of this for 16 observations for 16 people is 24. So when you will add 72 minus 50, don't add 72 here. Add 72, write 72 here and minus 50. So add 72 minus 50 into this to get the total for 17 people, which is 46. Same is here. Add 72 minus 50 whole square into this data to get the total for 17 people. Now you can easily get the standard deviation by using this formula. So we use this formula here. You can take the screenshot if you want of the solution. Next question. A sample of 36 data values is this and this. Find the mean and standard deviation. This is simple. By using this formula, assume mean formula, we can get the mean. Sigma x minus 45 over n, and this is 45. This negative is standard sign. This is the part of the formula, and write plus 45 here. So this result is minus 148, this is 36, and this is 45, and the answer is 40.9. This is the estimated answer, and this is the exact answer. Make sure you will use this number in later part. If you would need to use it, then use this number. Don't use this number. Always use the exact value in later parts. One extra data value 29 was added to the sample. This question is similar to this question. Find the standard deviation of all 37. You all know how to add 29 into this data. So x minus 20, x minus 45. This 29 means x. So you have to add 29 minus 45 into this. And 29 minus 45 square into this. And this is the formula of the standard deviation. And give your answer up to 3 significant figures. Next question. X minus 172, and this is also given. Mean is also given, 104.8. Find the number of children. So by using this formula of mean, we can easily get the value of n. Mean is this. We have this. So n is 15. Make sure n is always integer, positive integer, because n means number of people or number of student, means n is discrete. It is always positive integer. Now we need sigma x minus 140.8 whole square. So for that, we need to use this formula. I told you we use this relation during the questions. Since this information, we have these informations, we need this one, and unfortunately we don't have this one as well. So we have to first calculate this. We have this complete data. We need this thing, but we need this as well. So for that we need to use the formula of mean. So you can call this as equation number 1. This one is equation 1. We need this one. So for that we will use the formula of mean, and mean is 104.8. So with the help of this formula we can get this quantity, and the answer of this quantity is 0. So when you will put 0 here, you will get this answer. You can check the solution of second part or the entire question. The monthly rental prices for 9 apartments in a certain city are summarized as follows. The mean monthly rental is this. Find the value. This is so simple. We have x bar. So by using the formula of x bar, we can easily get the value of c. Because we have x bar, we have sigma x minus c, we have n 9, we can easily get c. Now the next thing is find variance. This is so simple. This is the formula of variance. We have all the informations. That's the answer. This is the exact answer. Therefore, I'm not giving this answer as 3 significant figures. Another apartment is added. Again, we have same question. Added. The mean monthly rental price is this. Find the rental price of this additional apartment. This is a different question. So when you add the price of another apartment into the data, the mean would be this. So this is the mean for 10 observations. So when you will multiply this 10 with this, you will get the total value of all 10 apartments. See, this is sigma x for 9 apartments. what basically we did, we multiply 9 with this number and we got the total value of all 9 apartments. So if we will multiply uh, this by 10, then we will get the uh, total value for 10 apartments. So sigma x for 10 apartments will be this, and sigma x for the 9 apartments uh, is 19845. So if you will subtract these two, you will get 1360. This is the value of the new apartment. So if you multiply this by 10, you will get the total value of all 10 apartments, and you have the total value of for 9 apartments. Just subtract these two to get the value of the new apartment. This is just one way, and this is the another way. Sigma x for 9, and if you add x here, then this will be sigma x for 10, and sigma x for 10 is this. So that's the answer. You can do this question in either way. Next question, we need the value of this. So we know this relation, the relation for standard deviation, and we have entire thing except this. So by substituting the values of all, we can get the value of this. If you know the formula, if you know the relation, the questions will be very simple. That is why I am asking you to learn this page. Understand and learn this page. See, I use this relation. This page is extremely important. Must understand this and must learn this. And the question will be very simple for you then. See, that relation is here. And this is the exact answer. So leave your answer as it is. Cambridge says give non-exact answers up to 3 significant. When answer is exact, then you can leave the answer as it is. And you should leave the answers as it is. Well, this is the group data, and we need a mean and standard deviation. You know, this is the formula for mean, and this x means the central value, like mid value or class centers, and we can easily get the values of x by taking the average of class intervals. So when you will take the average of 1 and 25, you will get 30. The average of these two will be 30.5, and so on. This total is 120. It's here. So mean is sigma fx. This is f and this is x. So 4 times 13, 24 times this, 38 times this, and so on. This is the exact answer and this is the estimated answer. Make sure you will use this number in later part. Variance. The formula of variance is this. Let me write the formula here. You don't need to mention the formula during exam, but for your conceptual clarity, I'm writing here. Sigma fx square. See the change in here and here. This is sigma fx and this is fx square. In fx we multiplied in this way, 4 times 13, but in fx square we will multiply this like this, 4 times 13 square, 24 times 30.5 square. So if you square here x square, f times x square, 4 times 13 square, then you will get this quantity, fx square, and this is the answer of mean. This is the standard deviation. Another question. Well, in this question, they are saying a histogram is drawn with a scale of 1 centimeter to 1 unit on the vertical axis, which represent frequency density, and from class 1 for the first class, the height or density is 3. Now find the value of x, and then find the density for this rectangle. You know, this is the formula for frequency density. The formula of frequency density, you did this in O levels. It's frequency upon class width. So frequency density is 3 of this class and the class width is 10. Make sure whenever you find class width from class interval, then count both the numbers. 1 to 10. Count both the numbers like 1, 2, 3, 4 till 10. So these are 10 numbers because both the numbers are inclusive. So make sure whenever you find class width from class interval, take both the numbers inclusive. So the class width of this interval is 10 and the frequency of this class is 2x. So by substituting everything into this formula, we can get x. Now we need frequency density of this. The class width is 20, frequency is x, which is 15. So the height will be 0.75 because 1 centimeter is 1 unit. Now we need mean. Mean is simple, you know, sigma fx over sigma f times this. You need to get the average of class intervals. This is the exact answer and this is the estimated answer. Give both the answers. Next question. This is question number 1 from my book. And this question is very important. The numbers of rides taken by two students, F and G, at a fairground are shown in the table. These are the number of rides: roller coaster, water slide, revolving drum. The mean cost of F's ride is 2.50. The mean cost of this F's rides is 2.5. And the standard deviation is 0. Standard deviation 0 means all rides must cost the same. This means all rides must cost the same, meaning this roller coaster ride cost 2.5 each, this cost 2.5 each, and since this is 0, so we are not sure about this cost. So you can write this here. The cost of this ride is 2.5. This is also 2.5 and we don't know about this because this is 0. So standard deviation 0 means there is no variation in the cost of the roller coaster and water slide. Or you can also say all rides must cost the same. This is the answer of first part. Explain how you can tell the cost per ride is same. Since standard deviation is 0, therefore all observations are same. Therefore all the cost of all rides must be same. Let me write this here as well. Since so all observations are same, therefore or hence all rides must cost the same. This is another way of explaining this answer. Both answers are right. You can represent your answer or present your answer in any way. Whenever standard deviation is 0, that means all rides must cost the same. And since this is 0, so we are not sure about this, the cost of this ride. Well, the second part, the mean cost of G's ride is 3.76 of this ride, G's rides. Find the standard deviation. Since we have mean, so we can get the cost for revolving drum. So by using the formula of mean, we can get the cost. And I am supposing this as y. This student suppose this as x. Let me suppose this as y. Otherwise, it could be mixed. This x could be mixed with this. So the cost for revolving drum is 4.60. Now we can easily get the standard deviation. This is the formula of standard deviation, and you know how to get the standard deviation. F times this, F times this, and F times this, like square. F times 1 times the square of this, 3 times square of this, 6 times square of this, and this is the standard deviation. You can check the solution. Next question. This question is of combined mean. Red Street Garage has 9 used cars for sale. Fairville Garage has 15 used cars for sale. This is the data for Red Street and this is for Fairville. 9 cars, 15 cars. The mean age of the cars in Red Street is 3.6 and standard deviation is this. In Fairville, sigma x is this and sigma x square is this. Now we need combined mean, and this is the formula of combined mean. So 9 times 3.6 sigma x, and sigma x is 64. You can write the sigma x here. Nine times 3.6. So this number is here. This student use this formula, and sigma f is 64 and 9 plus 15. Exact answer, estimated answer. We will use this answer in later part. Standard deviation. This is the formula for the standard deviation, and sigma x square. We discussed these formulas earlier in this lecture, so you must know these formulas. Make sure after this lecture you must learn these formulas. So sigma x square, red squid. This is for Fairville, and this is sigma. This information is given to find sigma x for Red Street square. So this information is for this quantity. So sigma x r square, with the help of this formula we can get its value, write all complete value or at least 4 decimal place value. Now we have the complete data. So by using the formula of combined standard deviation, this formula, we can get the answer. So sigma x r square is here. This is 352. Combined mean is here, and n1 plus n2 is here. That's the final answer, 3 significant. You can take the screenshot of this solution if you want. Well, this question is for mean and standard deviation. I'm leaving the first part because I will discuss histogram in representation of data in my next lecture, inshallah. You all know how to get mean. Take the average. So the average will be, I guess, 10.5 and so on. This is the formula of mean, and this is the formula for standard deviation. We did a question of this type earlier in this lecture, so you can just go through the solution. You can just go understand the solution, and make sure you use this value. Don't use this value. Now this question is important. The birth weights of random samples of 900 babies born in country A and 900 babies in country B are illustrated in these CF graphs. Use suitable data from these graphs to compare the central tendency and spread of the birth weights of the two sets of babies. Now central tendency means mean, median and mode. Spread means range, interquartile range, standard deviation and variance. Now you have to decide which particular central tendency will you use here and which particular spread you will use here. Now from cumulative frequency we can easily get median. We cannot get mean and mode from cumulative frequency. So we will use median from central tendency. And from cumulative frequency graph we can easily get the interquartile range. So we will use interquartile range for spread. So median for country A is this and median for country B is this. And lower quartile. Median, you can easily get median by taking the half of this 900. 450, this is median. And the half of 450 is 225, this is Q1. And the half of 450 and 900 is 675, this is Q3. I will discuss this more in detail in my next lecture, the representation of data. Well, these are values of median and IQR for country and country B. C, median. Median of B is greater than median of A. That means on average, country B has heavier babies than country A. You have to mention this thing. Since median of B is greater than median of A, therefore on average, country B has heavier babies than country A. Make sure you must write on average. This statement on average is compulsory because you are comparing their medians. Now we have to compare IQR. This IQR is large and this is small, so you will say since IQR of B is greater than IQR of A, therefore more variation in weights of babies in country B than in country A. Or you can say weights are more spread out in country B than in country A. Or more variation in weights in country B and than in country A. Babies of country B. Well, this is all. I hope this lecture will help you to understand the concept of this chapter well. Good luck, and an important advice for me and for everyone: we should be well mannered, and we should be careful regarding the well mannered. We should be extra conscious. We should always dress properly. We should always be humble, kind, down to earth, sincere with others, like these things. For example, these things, well mannered is a very you can say a large term or a very comprehensive term. So well mannered contains almost every good characteristic is in well mannered. So well mannered means we must have good qualities, and we must leave bad qualities, and we must adopt good qualities, and when we must strive to get good qualities, to achieve good qualities in our life. Allah Hafiz.